Okay, Unit 6, test review, pre-calc. Let's go. Starts off with a bunch of logarithms, so hopefully you guys are good and educated on that. So the first one says solve. Well, the two, notice we've got like bases, got to keep an eye on that. Addition simply means these two can combine. The two shall become one by multiplication, so log base 2, we multiply 4x equals, and then over on this side, I'm pretty sure it's supposed to be a parentheses there. We got the same situation. The two shall become one by multiplication, so this distributes through. We get log base 2, 5x minus 10. So, because this matches this, that means that this has to be the same thing as this. So the problem just got pretty easy. But there is a twist coming. So 4x has to equal 5x minus 10. I'm going to subtract 5x here, subtract 5x here, so I get negative 1x equals negative 10. So positive x equals 10. Now just when you thought you were done, you have to, on these problems where you have a logarithm, you got to pop that in there, make sure that doesn't turn that into a negative, and it didn't. Turn that in, pop that in there. 10 minus 2 is 8, so that's okay. So you just got to make sure your answers don't create negatives in your logarithm in those positions, because those are mathematical impossibilities. Let's just keep going here. Got a 3, got a 5. So we got a situation here, Houston. So we cannot combine these two because we don't have common bases. So we need to look at this differently and just think, okay, what the heck is this even asking us? Well, that's the same thing as separately taking this as its own logarithm problem and asking, wonder what that's equal. And that's 5 to the second power is 25. So x equals 2. So this whole thing equals 2. So this thing, I am able to condense it to minus 2. And then the same thing over here, that's just saying log of 2 to some power equals 16. 2 to the fourth power equals 16. So x equals 4, sorry. So that means I can replace this with what it equals, and that means I can replace it with a 4. And now this problem lost some of its sting. So I still have some work to do though. So 4 plus 2 is 6. So this turns into 3 to the 6th power equals x squared. And now I'm going to use my handy dandy calculator. Or I could actually not use my calculator right now. I'm just going to take the square root of this side. I'm going to take the square root of that side, take advantage of the rules that are provided for us. 6 divided by 2 is, well actually, bada boom, bada bang, do the right thing. Very important. Almost forgot that plus or minus rule, but 6 divided by 2 is 3. So I really get plus or minus 3 cubed, which is the same thing as plus or minus 27. Now again, we got to make sure we pop these back into the original, because if we get a negative in this spot, it's no good. So put a 27 in there, square it, no problem. Put a negative 27 in there, square it, we get a positive, no problem. So both of these are correct. All right, this one, we do have common bases. So the two shall become one by multiplication. Notice we got to multiply that by that, which is FOIL. I'm going to do this in my head kind of sort of, but x squared, and I'm going to get 2x, and negative 4x is negative 2x. And then negative 4 times 2 is negative 8 equals 1. And I almost forgot to bring that base along. So now I know what to do. Base, exponent, answer. It's going to be a little bit of a nightmare, but here we go. 7 to the first power is just 7 equals x squared minus 2x minus 8. So now I got to set it equal to 0 before I do anything else. Just got to get in the habit of doing that. And then we're hoping that this is factorable, and it is. X minus 5, x plus 3 will get the job done. So my two possible answers, x is 5 from here and negative 3 from there. Got to plug them back in. If I put that negative 3 back in here, negative 3 minus 4 is negative 7. can't have a negative in that position, so that cancels itself. If I put the 5 in there, I get a 1, ding, ding, ding. Get a 7 here, ding, ding, ding. There's my answer. This is called an extraneous root. Go up to here, divide by 200, divide by 200. Don't you dare multiply 200 by 1.5. That's breaking the rules of PEMDAS because you don't know what this is, so you can't multiply that. Gone. And so I get 1.5 to the x plus 2. I'm going to leave a little space here, and you're going to kind of see what I'm doing. That reduces, the zeros go away. 7 over 2 is just 3.5. Common basis, happy places, not happening. Slap a log on that side, slap a log on that side. And here we go. So clear that out. And I'm going to get log of 1.5 is 0.176, but law 3 says I can take an exponent and a logarithm and bring it in the front, so it's really x plus 2, and now I distribute, so I get 0.176x plus this times 2 is 0.352 equals whatever the log of 3.5 is, 0.544. Now it just gets a little wonky. Just got to deal with it. Subtract 0.352, subtract 0.352, and I get 0.176x equals, what is that? 0.192. So I'm going to divide by 0.176, divide by 0.176, and I get 1.09, approximately 1.09. And take a look at the problem. It's not a logarithm, so no worries. This could be negative, not worried about it. This guy here, 3 and a 5. Common basis, happy places, not happening, so I got to slap a log on those. That allows me to bring the x plus 2 in the front. That allows me to bring the 2x into the front. Let's figure out what log of 3 is. 0.477. So I get x plus 2 times 0.477 equals, and then that 2x comes in the front of whatever log of 5 is, 0.698. How about we get crazy? Call that 0.7. Looks like that's a fair shake. So I'm going to distribute. So I'm going to get 0.477x plus times 2, 0.954 equals, this is 1.4x. So this is going to get a little weird, but 0.477x, I'm going to subtract, gather my x's, and then I get 0.954 equals 1.4 minus 0.477. I get 0.923x. So I got to divide by 0.923, divide by 0.923, 0.954, divided by 0.923. 1.033. So approximately 1.03. Let's get crazy and call that 0.4, round it a little bit. All right, yeah, those are not the easiest problems, but I hopefully understand the basics. This guy, well, it's a logarithm, so treat it like one. We're going to start here, go there, there. So it's 3 to the 4th equals x squared minus 1. I'm going to add 1, add 1. I know this is 81. So 81 plus 1 is 82 equals x squared. Bada boom, bada bing, do the right thing. We could break that down. I guess we couldn't. So what I'm going to do is turn that into a number though. So when I plug it back in here, I can think. Maybe not necessary, but I'm going to do it. The square root of 82 is 9.05. We know the square root of 81 is 9, so it makes sense. So we get plus or minus 9.055, we'll call it. All right. Well, if I plug a positive in here and square it, I'd get definitely a positive. if I plug a negative 9 point whatever in here squared, it's positive, and it's like close to 81, minus 1, positive. So both of these are correct. Don't forget to plug those back in. Okay, so we're on to some story problems now. How long will it take? So they're saying find time. But now the question is, what formula do I use? An investment earning 4.3 interest compounded quarterly. That means 4 times per year. That means I got to choose this formula, 1 plus r over n to the nt. Multiple times per year, got to use that formula. So it's asking how long to double. So that means if I invest $10, it's going to turn into 20. If I invest $100, it's going to turn into 200. If I invest $1, it's going to turn into $2. I'm going to keep the numbers simple. So it's going to grow into $2. My initial investment's $1, and then 1 plus the interest rate is 4.3, so 0.043, 4 times a year, and then 4 times a year times t. I'm trying to find t. I know that's a 1. I could divide both sides by 1. That's not going to change anything. But to get my exponent down in here, I'm going to take the log of both sides. But I'm going to figure out what this is first. So here we go. Clear. 0.043 divided by 4 plus 1. So 1 point, I'm going to keep all that, because if you round too much, this gets a little wonky. So 1.01075 to the 4t power. Now I'm going to slap a log on this side and a log on that side, and then bring that in the front. So log of 2, 0.301. Now I'm going to bring that in the front. 4t times log of 1.01075. 0.00464. Just getting really accurate here. Times 4, because I'm going to multiply that by that, and I get 0.301 equals 0.018575t. So now I'm going to divide by that. Probably should have rounded. 0.018575. So 0.301 divided by that crazy 0.018575, and I get approximately 16.2 years is how long it's going to take for that to happen. A lot of work. All right, next math problem. It says a national park has deer population of 5,000 in the year 2016. Very important. Conservationists are concerned because the population has exponentially decreased to 3,740 by the year 2020. Write an equation to model the deer population after 2016. That's a lot of information. Give me a second here. Okay, so just wanted to list all of these things. This is your generic exponential equation, and it says population has exponentially decreased. So we're talking about decay there, exponential decay. So a couple clues. B is less than 1. It's never negative, but it's less than 1. But we're really going to focus on this particular model or function equation because it's decreasing to 3740. Now, if we take 5,000, that's initial population, subtract okay, because I'm in a hurry, I caught myself in a mistake. You guys probably noticed I stumbled there. I was going to subtract 3740 from 5,000 and then figure out the kind of the rate, and it's going to be negative. But this is the problem. 2016 to 2020, that's 4 years. And when you figure out the rate, it's always per year, so that's going to cause an issue. And because I'm in a hurry, it's a little bit of a stumble, but here we go. What I noticed is, if we focus on this, this is what the new population is. So we're going to fill that in, 3740. I was picking the right formula, I just had the wrong plan of attack. The initial population was 5,000. Remember, it's decay, it's decaying, it's going down. And the only variable we don't know is R. So that's what we're going to try to find, and that's what this is saying. Write an equation to model the deer population after 2016. So what we're doing is we're trying to calculate R here, which we can do because T is 4 years. So now I'm going to divide both sides by 5,000. And now we're on our way just to finding T. So here we go. 3740 divided by 5,000 is 0.7748 equals 1 plus R to the 4th. Now I'm going to take the log of this side and the log of that side and let math be math. So log of 0.748 is negative 0.126. That 4 comes in the front, and then I'm left with log of 1 plus R. Because I don't know R, I can't take the log of anything. So I'm going to divide by 4, just cleaning this up. So negative 0.126 divided by 4 is negative 0.0315 equals log 1 plus R. There's an invisible 10 there, and this is how we're going to find R. 10 to the negative 0.0315 power equals 1 plus R. This to this power equals that stuff, the very definition of a logarithm. So we're going to go 10 to the power of negative 0.0315, hit enter, and we get 0.93 basically equals 1 plus R. Subtract 1, subtract 1, we're almost there. Negative 0.07 is our R. So really, it's decreasing at a rate of 7% if you want to wrap your brain around that, but it's saying build a model. So now we know that after 2016, the answer to that would be the amount, the population after time. So we're just building a generic, is the initial value 1 minus 0.07 to the T power. Maybe one more step would be 5,000 to the 0.93 to the T. And I would accept either because they're pretty much the same thing, but this is just cleaned up a little bit. There's our A, there's our B, which we knew was going to be less than 1, and it is. All right, now we're going to apply what we found. How many deer will there be in 2029 according to the model? Well, from 2016 to 2029, that's 13 years, so we're going to use this. See, the amount of deer will be 5,000 times 0.93, what did I say, to the 13th power. So I got to take this, 0.93, raise it to the 13th power, multiply that by 5,000, and we'd have approximately 1,946.47 deer. So maybe 1946, round down to the nearest whole number. And that should finish this first video. Seems like a good stopping point.